Welcome back. Today, we're going to jump into what we've been working for this whole time, which is simplifying square roots. That's right, we're finally doing it. For now, let's begin by first talking about perfect squares. What are perfect squares, you ask? As a reminder, perfect squares are numbers, where there's a different number out there, where if you square it, which means if you multiply it by itself, you get the number we're talking about here. So we have a bunch of perfect squares I've asked you to memorize this whole time. They are, for example, 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36, 7 squared, which is 49, 8 squared, which is 64, 9 squared, which is 81, and 10 squared, which is 100. So we have these perfect squares here, and these are numbers that you must memorize. These are really important, as you'll see when you look at examples like this. Let's say, for example, we have root 16. Well, that's pretty easy. We know that's 4, right? Because 4 to the power of 2, 4 times 4 is 16. But what if you had a trickier number? What if you had a number like, say, root 18? Well, 18 is not on this list of perfect squares, so there's no one number where if you multiply it by itself, there's no one integer, where if you multiply it by itself, you get 18. What are we to do now? Well, we know we can factor this out. We know that root 18, we can look at the factors of root 18, which are the numbers where if you multiply them together, you get the number inside the radical. So, for example, you have root 1 times root 18. I also notice that 1 is the first number on that perfect squares list. Well, that's just equal to 1 times root 18, and that's just root 18, because root 1 is equal to 1. That's not very useful, right? We're just back to where we came from. But let's look at the perfect squares again, because remember, we're talking about how we need to factor this out into perfect squares. I know here the root 18, looking at 4 doesn't go into it, so I need to look at different numbers. But I do know that 9 does go into it. 9 times 2 is 18, so root 9 times root 2 is equal to root 18. And then, what I end up with then, that's equal to 3 times root 2, because root 9 is 3. 3 to the power of 2 is 9. And finally, when I have 3 times root 2, I look at the 2 inside the radical. I can't simplify that anymore. So I'm going to write that again as 3 root 2. Can't be simplified any further. This is how we simplify. Notice how the 3 times root 2, I just wrote that as 3 root 2. I'm going to box that right now. The reason why I can do this is because we know conventionally that when you have a number in front of a radical and you're multiplying them together, you do not need to add the multiplication sign. So, in conclusion, root 18 is equal to, once and for all, 3 root 2 in its most simplified form. Now, you might also be wondering, what if we did root 2 times root 9? 2 times 9 is also 18. Would that work too? Well, you're absolutely right. That would work. I'd write that as root 2 times 3 because root 9 is equal to 3. But then after that, I would also write the final answer as 3 root 2 because I just think the whole number looks best when it's outside the radical in the front and not in the back. So once again, try to make sure that your whole numbers are in the front of the radical and not in the back of the radical. So there you have it. This is how you find any fully simplified form of any positive square roots. Now to simplify, I want to find factors that are square roots, so I'm going to keep the perfect squares list on top as I solve things like root 32, for example. Looking through the list of factors, well, I know 1 goes in, right? So root 1 times root 32, that's equal to root 32. And root 1 is 1, so that's 1 times root 32. And finally, that whole thing is equal to root 32. Now, we're just back to where we came from, right? That 1 honestly is not very useful here. So not all factors are created equal. Let's try this again using another number. For example, root 32. That's equal to, well, 1, we already used that. But what about, say, 4? What about 4? 4 times 8 is 32, right? So I'm going to write root 32 is equal to root 4 times root 8. Now you're going to see why I put that root 8 in blue in a bit. But first, we know that root 4 is equal to 2. So that whole thing is equal to 2 times root 8. So that whole thing is 2 times root 8. But that 8 actually has a factor that's a perfect square in it too. Can you figure out what that is? Well, if you look through the list of perfect squares, well, obviously 1 is a factor, but we've all kind of established that 1's kind of useless at this point. But we still have 2 times root 8, which can be turned into root 4 times root 2. Notice how we did that. We just took that root 8 and we factored it again. So we're factoring twice this time. Well, that whole thing is equal to 2 times, well, root 4 is equal to 2. So that's 2 times 2 times another root 2, which gives us the following. It allows us to then multiply that tan number and the blue number together. So 2 times 2 is 4, and that whole thing is equal to 4 times root 2. And as I said earlier, in this kind of situation, we just take out the multiplication sign to get 4 root 2 as a result. So that should be our fully simplified version of root 32. So I'm going to box that right here. Now, I also want to point out that you could just get really lucky from the very beginning. For example, you have root 32. You can just turn that into root 2 times root 16, for example. You can notice that the 16 is a large number that's a perfect square. Well, that whole thing is just equal to root 2 times 4, because root 16 is 4, and that becomes 4 root 2 as well. Notice how the integer at the back goes to the front again. Either way, you get the same answer. The way we did it is kind of a long way around, but it will get you that answer. And if you feel confident and comfortable, you can use a short way around to get the answer as well. Just make sure you're using a perfect square each time. Let's just look at one last example before we wrap things up. Let's say, for example, we have root 72. Well, as I said earlier, you could get lucky from the very beginning. You can notice that, well, 36 goes into this, and 36 is a perfect square too. So I'm just going to write root 36 times root 2, and that's equal to 6 times root 2 because root 36 is 6, and that gives us 6 root 2. Notice how that multiplication sign in between goes away, and that 6 is by itself in the front of the root 2. That's your fully simplified form because 2 cannot be factored anymore besides 1 times 2. And once again, 1 is useless here. But let's say we were not as lucky from the very beginning, and we didn't have that lucky guess or that lucky intuition. Then we can just still do this a long way around. What that means is we go down the list from left to right and check and see whether each perfect square is a factor of 72. 1, I don't want to keep dissing 1. I feel like I've been dissing 1 too much, but 1 is pretty useless here. I'm really sorry, 1. It's very useless here, but 4 here is not as useless. So I'm going to take out that 4 and know that 4 times 18 is 72. So that whole thing is equal to root 4 times root 18. As a result, I'm going to write this in tan and blue because of the fact that I want to show that root 4 is equal to 2. But then I notice that the 18 can be factored again. How can 18 be factored? Well, 1 goes into 18, 1's useless. 4 does not go into 18, but 9 does. So that root 18 becomes root 9 times root 2. So the whole thing becomes 2 times root 9 times root 2. That root 9 becomes a 3, so that becomes 2 times 3. So as a result, this whole thing leads to 6 times root 2, which gives us 6 root 2, just as we have at the very top. Notice how each way, whether it's you having good intuition for this or a lucky guess that allows you to do it quickly, or if you have to do it the long way around, either way is fine. Just make sure you're checking to make sure that inside the radical, there's no more perfect squares that are factors left over. Now, just to close out with some vocabulary, ultimately we're just trying to simplify square roots here, by finding factors that are perfect squares. This is what we did in the previous lessons too. But then we're actually solving it out so that there's no more perfect squares remaining under the radical. For example, if this root 24 is equal to root 4 times root 6, that's 2 root 6 is equal to just 2 root 6 here. There's no perfect square that goes into 6 besides 1, which as we've established again and again, I apologize to those of you that like 1, but 1's really useless here. There's no other perfect squares besides 1 underneath that radical. So that means that this right here is a fully simplified form of root 24. Now, finally, this question to think about should have been answered if you were paying attention really closely to the video. But there's just multiple ways we can simplify some square roots. For example, root 12 can be simplified in these two ways. Which one of these would be considered fully simplified? Well, as we've established again and again, we need to make sure that there's no more perfect squares that are factors inside the radical. So the top one is good because 3, the only perfect square is 1 and it doesn't count. But with 12 on the bottom, we're just back to where we came from, and a 4 goes into there too, and 4 is a perfect square. So there you have it. This is how you simplify square roots. You find perfect squares, and you simplify it by factoring it out. This relies on a lot of progress we've made so far regarding exponents, regarding square roots, regarding factoring, regarding all kinds of different things, and I'm really proud of the progress you made so far, and I know that it's going to set you up really well for high school and beyond, the fact that you know how to simplify square roots now. For now, best of luck in the work. Make sure to like, comment, subscribe once again, and see you next time with another video. Take care.
Don't let the past repeat.